Hello everyone, welcome to 7.2. It's about right triangle trigonometry, and we start with 6 trigonometric ratios. There are 6 trigonometric functions. Now if you think of trigonometry itself, it's tri and gono and metry. Those are the 3 parts, right? Tri, gono, sorry, I broke the trig. Okay, tri, gono and metry. So tri is 3, gono is like angles, and metry is the measurement. And we're going to do this, we're going to measure the angle. So you can see that it's to do with a triangle, or you could put the triangle inside a circle because it's angles. And so the whole idea of finding these angles using new functions, trigonometric functions, is the key idea here. So think of a right triangle, because it's all about right triangle here. Right triangle affords us many advantages. The simplest advantage is that you can use the Pythagorean identity. We know a right triangle is a triangle that has at least one angle as 90 degrees. And we know all 3 angles in a triangle add up to 180 degrees. So if this takes up 90 degrees, the other 2 angles must be less than 90 degrees, right? So they are called acute angles. So 90 degrees, one of the angles being 90 degrees is what we mean by a right triangle. Sometimes a right triangle could look like that. Oops. Could look like that. Okay, that looks terrible. Not like that. As long as you can make that box-like angle, you know it's 90 degrees. So don't be fixed on the standard shape we see. I will use the standard shape mostly just to get the problem done. But always remember that your right triangle need not always be flat, sitting on a base like that. All right, coming back here. Now this is 90 degrees, so there is no problem about that particular angle because it's known to us. So think of the other angles. We know the other angles are going to be acute, meaning less than 90 degrees each, but we don't know what they are, right? Now let's just talk about the parts of the triangle in terms of Pythagorean identity, okay? Or Pythagorean theorem in this case. The Pythagorean theorem says c squared equals a squared plus b squared. So what is c squared? What are a and b? C squared is always a hypotenuse, and you have 2 other legs of the triangle. So that's one leg and that's the other leg. So how do I know which one is the hypotenuse? Hypotenuse is always the side opposite to 90 degrees. Always. So here I have 90 degrees. So its opposite side, this must be the hypotenuse. And there's also another relation in geometry. The side opposite the largest angle is the longest side. And the side opposite the shortest angle is the smallest side. Because of that relation, you can kind of think of it, right? It can only open so much because the angle is small. So the side opposite that will also be only so much. So it's going to be short. On the other hand, if your angle is really large, it opens wide, the angle opens wide, therefore spanning the distance between those 2 ends to be a long side. And so because of that, your hypotenuse will always be the longest side, because 90 degrees will always be the largest angle we can find in a right triangle. If it's not a right triangle, of course, you can have a triangle that is obtuse. So it's like you're leaning back on the chair, right? So that is more than 90 degrees. Then we don't use the word hypotenuse anymore, because hypotenuse is related to only the right triangle, and a right triangle will always have one of the angles to be 90 degrees. So that is assured. If I were to position them as A, B, and C, hypotenuse will always be C. A and B could be any of the other 2 sides. So that could be A and this could be B. They both are called legs of the triangle, and they're of course the shorter legs. And so it can be interchanged, A and B. So in this triangle, this is my C, hypotenuse is my C. And this could be my A and this could be my B. Okay. All right, so how do we define these 6 trigonometric ratios? Now, first of all, we want to understand that although there are 6, they are generated by 2 of them. We have 2 parent functions, and they, when you work on them, you are able to generate the other 4. Okay, and even we can even compress that and bring down to 1, because those 2 are themselves are in some way connected. Anyways, let me just keep it simple now and draw another right triangle. Again, I like to draw it in the standard form, so I just put it like this. Now, let's talk about the angle, because that's the focus here. So theta is the angle, okay? And you are always interested in knowing how to measure the angle. Now, we've always thought of measuring the angle with a protractor, an equipment, right, to see the angle in 30 degrees, 50 degrees. What's really cool with trigonometry is we don't have to do it using a protractor or some kind of equipment. We're going to find the angle using the sides, and that is powerful. So you don't need any special device, but you can just use the sides of the triangle to measure the angles, and that is powerful. So we always look at the angle of interest. So if the angle of interest is theta, then you look at the side opposite that, and we call it the opposite side. I'm going to color code this so you can see that that's the opposite side. Because of the 90-degree mark here, this is always going to be the hypotenuse. So opposite side is the side opposite the angle theta. Hypotenuse is always opposite the 90 degrees. The leftover side is always called the adjacent side. That makes sense because it's adjacent to theta, right? It's touching theta. So we have these 3 positions. That is how we use the ratios. Ratio means fractions, right? So we generate these functions by setting these fractions. I also want to point out that, say this was your angle of interest. Let me call it differently. I'll call it alpha. Remember, we use Greek letters to indicate angles mostly, but it could be anything. You can have sine x. You can have x as the angle. You can have t as the angle, or you could just have these Greek letters. So if alpha is my angle of interest, I'm using different colors so you can see that the way these players will change. So if alpha is the angle, its opposite side will now be the opposite. And the hypotenuse remains the hypotenuse because it's still opposite 90 degrees. Nothing changes there. I'm putting that, all the green ones in parentheses. And the opposite side in the blue will now become the adjacent side because that's the leftover side after I have fixed the opposite and the hypotenuse. So we have to be super careful which angle we're talking about and then considering its opposite side and adjacent side. Okay? All right, let's begin. So the first function is called the sine function, S-I-N-E. And as a shortcut, we write S-I-N. So please do not pronounce it as sin, it's sine. Okay. Sine of an angle, okay? Sine, this is all about the angle. So how do I measure this angle? If I use the sine function, sine of the angle theta is defined to be opposite side over the hypotenuse. This is how the ratio is set up. And please remember that you will never write a sine by itself. Sine has to be accompanied by the angle. Otherwise, you're not really measuring the angle. Okay? So sine theta is the angle for sine function with opposite over hypotenuse as the ratio. Then we have cosine function. Cosine function, the shortcut is cos. Again, it's the same angle theta that I'm interested in. And that is defined to be adjacent over hypotenuse. These are the 2 main functions, or trigonometric functions, that we will use to generate the remaining 4 to form 6 trigonometric functions. Okay? And then we have tangent function. This is a very important function, tangent function. And the shortcut for that is tan theta. Tangent is originally defined as sine theta over cosine theta. It's the ratio of the other two trig functions. Tangent is the ratio of sine and cosine. So tan theta is sine theta over cosine theta. If you go back, sine theta itself is opposite over hypotenuse. And cosine theta is adjacent over hypotenuse. If you were to simplify this, you get opposite over hypotenuse times the flip of the denominator, so hypotenuse over adjacent. Then if you cancel them off, you get opposite over adjacent. So ultimately, tan theta is opposite over adjacent. Once again, you cannot have any of these functions without having the angle in it, tan theta. Don't just say tan. So we can also change this theta, as I mentioned before. You can change it to x, and you can call it tan x, where x is now the angle. You can call it tan t, where t is now the angle. Tan s, s is the angle. Tan alpha, alpha is the angle, and so on. So please feel flexible to use these letters or symbols. So I'll just write that here. Alpha is this symbol. It looks like an A, but these are Greek letters. So this is alpha. Beta also looks like B, but you can see that the B is stretched. And theta is an O with a line through it, a line across it, sorry. Okay. Because a line through it is a different symbol. Anyways, so we've got sine, cosine, and tangent. And to remember these ratios, there is a, what do I say, a mnemonic to remember this relationship. So if we want you to, how do I, okay, I'll just highlight it with this, highlight, okay, S-O-H, right? Sine is opposite over hypotenuse, S-O-H. So then you have so, S-O-H. And then you have C here, A-H. Car, C-A-H, car. And this one is T, O, and A, TOA. So together, it's SOCATOA. That's your way to remember this. SOCATOA, SOCATOA. Sounds fine, right? Sounds like some exotic Hawaiian island. Well, it's a good image. SOCATOA is a way for you to remember this, okay? Sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. We'll talk about the other three sine trig functions later on, because these are the primary ones. So let's just get our understanding very clearly here. Okay, if I give you this triangle, do you know that this is a right triangle? If you can form that box, it's a right triangle. And this is given to be alpha. And the other positions are the sides given to be 21 here, 75, and 72. If they ask us to find sine alpha, then you want to pay attention to where alpha is and go for its opposite. Its opposite side is 21, so that has to be opposite. And opposite side of 90 degrees, opposite of 90 is 75. So that is your hypotenuse. You also know the hypotenuse is the longest side of the three, and that is 75. That's the largest number of the three. So it's all lining up, good. The leftover one must be adjacent, and you look at it, it is adjacent to alpha. It is right next to alpha. All right, so SOCATOA, so S-O-H is opposite over hypotenuse. So you know that the opposite value is 21 over the hypotenuse is 75. Okay. Of course, wherever possible, you will be simplifying it. Okay. So go ahead and simplify it, but I'm just going to show you just the position, so I don't want to simplify it now. In an actual problem, we will. Right now, we're just exploring this idea. Cosine alpha would be adjacent. So ka to ka, K-A-H, would be adjacent over hypotenuse. That is 72 over 75. And tan alpha, so ka toa is opposite over adjacent. The opposite is 21 over adjacent is 72. So you can see their positions. So you are able to find the measures for these particular functions using these ratios, right? Now let's talk about the other trig functions. So we call them reciprocal trig functions. And why is that? Because they are reciprocal of these three functions. So let me quickly write here. Sine theta is opposite over hypotenuse. It's always good to write it because that's one way to memorize it without forcibly memorizing things. Right? Adjacent over hypotenuse. And tan theta is opposite over adjacent. Quickly check. So, ka, toa. Okay. Now, these functions have their corresponding reciprocal functions. Okay. So, the reciprocal means the flip, right? So, reciprocal is a flip. So, reciprocal of opposite over hypotenuse is hypotenuse over opposite. Reciprocal of 2 over 3 is 3 over 2. Reciprocal of negative 1 over 5 is 5 over negative 1. So we understand reciprocal is the flip, right? And so what we do here is we are saying, well, the reciprocal of sine is 1 over sine, right? And that has a new name. 1 over sine is cosecant theta. Okay? And the shortcut for that is CSC theta. We want to have just 3 letters, so it is CSC, cosecant theta. You can't read it like cos or tan. You have to say cosecant. It's kind of hard to pronounce it otherwise. So if you look at cosecant theta, if it is the flip of sine, then opposite over hypotenuse becomes hypotenuse over opposite. Okay? And then we have cosine. The reciprocal of cosine is 1 over cosine theta, and it's got a new name. This reciprocal has a new name. It's called secant theta. And secant shortcut is SEC, secant theta. And adjacent over hypotenuse is cosine, so the reciprocal, which is now secant, would be hypotenuse over adjacent. And lastly, reciprocal of tan is 1 over tan theta, and it's got its reciprocal name, which is cotangent theta, and the short form for this is cot, C-O-T, cotangent, cot theta, which is going to be the flip of opposite over adjacent, making it adjacent over opposite. Okay, so if you go back to this problem that we just saw, we can now do the other functions, right? So if I were to do the reciprocal of sine, okay, the name for it is cosecant. So they said find, oh, it's alpha, not theta. In this problem, it's alpha, right? There's no, so you have to stick to that problem's notation. So cosecant alpha is the flip of sine. So you have to go hypotenuse over opposite. Okay? Or because we just found these numbers here, you just flip the numbers, which is hypotenuse over opposite. And then the reciprocal of cosine alpha is secant alpha, and that will be 75 over 72, but that's actually your hypotenuse over adjacent. And lastly, the reciprocal of tangent is cotangent. Cot alpha is 72 over 21, which is adjacent over opposite. And this was the reason I didn't want to simplify these fractions. So technically we should, it's an unsaid rule, but I wanted to see, keep them the way they appear on the triangle. We have that here, okay? So I have introduced to you the 6 trigonometric ratios. Now we will talk about using right triangle trigonometry in solving problems. So lengthy. So when we say solving problems, this is problems related to the triangle. So if we had any missing information, we can actually use the idea of the concept of trigonometry, these 6 trigonometric functions, to find the missing information. Okay. So here's our first question. I mean, this section is to do with missing side lengths. That's too spaced out. So then we say, find the missing side length for this given triangle. And you know, the edges of the triangle, the vertex, they have to be always written in capital letters. So you have A, B, and C. Okay. And the norm is that when we write them as A, B, and C, you can choose any corner to be A, B, and C, that's fine. But once you have fixed the positions, the side opposite capital A will always be small a. The side opposite capital B will always be small b. The side opposite capital C will always be small c. Okay? And apart from that, if you have further details, like once you know the angle, then you have the opposite, adjacent, and all that. So I'm going to give that information as well. So you have this angle given to be 34 degrees. Okay, that looks like 340. Put the degree, yes, 34 degrees. We have the 90-degree angle, so you know that your C is the hypotenuse. It so happens that way, but we always choose C to be the hypotenuse, just because in the Pythagorean theorem, your C is the hypotenuse. So always try to, as much as possible, try to keep your 90-degree mark as C so that the opposite side will always be a small c. And because 34 degrees is marked here for angle A is 34 degrees, its opposite side, small a is the opposite, and this one will be the adjacent, B will be the adjacent. Okay. All right, so in this, find the missing side, and they're asking us to find length B. Find length B. So you're just trying to find B. And C is given to be, all that I'm writing in black is what is given to us, okay? So this side is called B, and this length is given to be 220 inches. So it's trying to kind of do some instruction on that triangle. And so all that is in black is instructed for us, okay? So B is given to us, 220 is given to us, angle 34 degrees is given to us. For the time being, I'm going to erase all the red marks. Okay, so 220, B, and 34 degrees. Now we have to focus on using the appropriate trigonometric function so that we could utilize what we know with what we don't know. So you're going to try and create a bridge between the known and the unknown. Okay. For that, let's first go back to assigning the opposite, adjacent, and hypotenuse. So this is the opposite. This is the adjacent we saw, and this was the hypotenuse, right? Now we have no information about the opposite, right? There is no information on the opposite. That means you only have to contend with adjacent and hypotenuse. Go to your formulas and see which trig function connects the adjacent and the hypotenuse. Okay? You can remember from SOHCAHTOA, but you can also see that cosine theta is the one that connects adjacent and hypotenuse. So that is the appropriate function for us to use. So cosine, in general, cosine theta is adjacent over hypotenuse. In this particular problem, theta is given to be a specific angle. Cosine 34 degrees is adjacent, which is the unknown side B, over hypotenuse, which is given to be 220. This implies if you solve for B, B is 220 times cosine 34 degrees. Now use your calculator, and please be careful. When you try to find angles, measures for angles, you always want to make sure that you're in the right mode. So make sure you have the degree mode, because you have the degree mode and the radian mode in your calculator. So make sure you switch to the degree mode, and use the cosine button, locate the cosine button. So cosine 34 degrees. If you did not use the right mode, it's going to give you wrong, different answers. You just won't know it is wrong unless you've been observing it keenly. And if you're observing that keenly, you wouldn't have missed out on setting your mode to the degree mode. In this case, it's the degree mode, and then we have to use the calculator to get that answer. Keep the calculator answer the full form it is in. Okay. And then get the approximate answer, which is 182 inches. You have to say inches because 220 was given in inches. But it's approximate because you have rounded it. So you will say the length of the missing side is approximately 182 inches. So I'll give you another problem. So here again, you have a right triangle, and I'm going to fix that as C, and these two can be, any of them could be A and B. (23 degrees there and 16 meters here. This is what is given to us, and they're asking us to find the missing side. In this case, they did not specifically say which one it is, but the missing side is supposed to be the C there, because C is unknown here. And they want us to round the answer to the nearest whole number. So as always, look at your angle, and the side opposite that is the opposite side. And this is the adjacent side, and this is the hypotenuse. Hypotenuse is the missing information. So you want to make a bridge between hypotenuse, the opposite, and the angle, because adjacent, we have no information on the adjacent. So again, go back to your trig functions and see which one connects the opposite and the hypotenuse. So SOHCAHTOA tells you that sine theta is opposite over hypotenuse. And we have sine theta is opposite over hypotenuse. That's the general form. But theta is given to be 23 degrees here. Sine 23 degrees is equal to opposite, which is 16 meters, divided by hypotenuse, which is the small c. This implies when you solve for small c, you get 16 over sine 23 degrees. Okay. Again, use your calculator, find your sine function, and then enter 23 degrees again, because you have set it in the degree mode. It must be giving you the answers already in the degree mode. And so C approximately is 41 meters. We were asked to round to the whole number, nearest whole number. So I rounded it to 41. 41 meters is the approximate length of the missing side. Then we also have something called angle of elevation and angle of depression. So angle of elevation, as the name says, from the line of sight, okay, your line of sight is the horizontal line, right, where you can look. So your line of sight is a horizontal line, and if you are looking up, then that is angle of elevation, right? So you're looking up. The elevation is from above your line of sight. On the other hand, angle of depression says that, once again, your eye level is the horizontal line, and if you're looking below that eye level, then you are talking about the measure of the angle that is below your line of sight, the angle of depression. This is usually used when we are talking about buildings and shadows and examples like that. So think of it as real world examples in those settings where we talk about angle of elevation and depression. So if you're looking at an airplane going above, so from the ground level, that will be angle of elevation, right? And if you're in the plane and you're looking down, then that will be the angle of depression. Think of this example here. What you see here as the irregular blue shape is a lake, okay? And it represents a lake, and the distance across the lake, okay, the distance across the lake A is unknown, okay? And to find this distance, a surveyor, okay, let's say we draw, no, he has too many limbs, okay. That's fine, okay. Oh my gosh, I can't even draw stick figures. Okay, so the surveyor is standing here at A, right? And he's taking the measurement, he took the measurement. And from here, just standing at this end, is there a way for him to measure the distance across the lake A without having to take a tape with him and row all the way across to measure it, right? So that's the question. And can trig help us to do this without, from the convenience of staying at one end of the triangle? So let me add more details that they've given us. The surveyor made sure that the distance from his end of the lake to where he's standing is 750 yards. And the angle of elevation, right? This is his eye level, so angle of elevation here is 24 degrees. So he's got all these details, he needs to find the A. Of course, we can totally find this. And because this is the angle that's given to us, 24 degrees, look at its opposite side. So A is the opposite side, the missing side is the opposite side. And C, opposite side of C is the hypotenuse. And this must be the adjacent, 750 is the adjacent. Now, again, look for relationship between opposite and adjacent because there is no information on the hypotenuse. So opposite and adjacent, if you go back to our SOHCAHTOA, opposite over adjacent comes from tan theta, tangent theta. Tan theta is opposite over adjacent. And in this case, it's tan 24 degrees, which is opposite the missing side A over the adjacent side, which is 750 yards. This means that you solve for A, and it gives us, let me write the number first, 750 times tan 24 degrees. Again, use the calculator, and your approximate answer for this would be 3333.9. 333.9. And this is in yards, right? Then you come back and say the distance across the lake is approximately 333.9 yards. It's really cool that the surveyor doesn't have to take any equipment to measure that distance. If the angle is known and then the side is known from his end of the lake to where he's standing, that it gives him the ability to measure the distance across the lake. How about another scenario? Okay, you cannot mistake this. This is a tree. Okay, and then we have the beautiful sun. The blue sun, so I have to make it yellow now. And then the tree is lovely green. I'm desperately making up for my bad drawing. Okay. And let's draw okay. So you are standing a certain feet maybe away from the sun. Okay. And if you are able to measure this distance from the foot of the tree, and if you draw a vertical line, oops, okay, you draw a vertical line, then what you have constructed is a right triangle. Right? And let me fill you with all the details that are given to us. Okay. So we're talking about the shadow of the tree. Okay, what is the shadow of the tree? So at a certain time of day, the angle of elevation of the sun is 40 degrees. So this is 40 degrees. To the nearest foot, find the height of a tree whose shadow is 35 feet long. So you don't have to climb up the tree to find its height, but you can find the height of the tree by looking at the shadow. So the shadow is 35 feet long. And so we call the missing side of the tree as the unknown side. Okay. Let's just say tree's height is how I call it. Tree's height is what we're trying to find. And your angle is 40 degrees. So tree's height is the opposite. The connection to the sun, that line is the hypotenuse because it's opposite the 90-degree mark. And this will be the adjacent. Once again, you want to see what connects you to the opposite and the adjacent. The hypotenuse is not in the picture. And so you have tan theta is opposite over adjacent. And in this case, theta is 40 degrees. Tan 40 degrees is the tree's height, because that's what I called it. I didn't call it A, B, or C. Over adjacent, which is 35. If tree's height is too long for you, of course, that's why we use variables. You could just call it H. Okay. All right. So the tree's height is 35 times tan 40 degrees. And that will be approximately 29 feet. Because the shadow is measured in feet, so the height that you get from this will also be in feet. The height of the tree is approximately 29 feet. So I hope you enjoyed this video. I will see you in the next section. Take care.